Hello, this is Team Tim, also known as Team EPU. Today we will present our design project. My name is Amar Khalid, and my teammates are Abdulaziz Al-Mufarraj and Tyler Watson. So let's get started. The what and why. The design project will improving each day since the start of the semester is for the city of Sparkyville. The city of Sparkyville is in growth, and with its growth, it needs a sustainable, reliable, and renewable source of power to ensure its future. So we came up with the problem statement, which is to build a reliable and highly effective source of power. The team developed requirements and goals for the design. The requirements are that the design project needs to be eco-friendly within the given dimensions of the platform, which is 1 by 1 by 2 feet. It has to be freestanding, and it also has to use only the given resources. The goals we came up with are the design project has to be sustainable, cost efficient. We have a limited budget and we have a limited space and time. It has to produce a high quality electrical energy, and it has to be durable.
Hello, my name is Aziz, and I'm going to talk about 3 detailed sketches. The first sketch is, starting from the left here, is the main shaft. The main shaft is the same as the main dowel for the water wheel, and it's actually connected to 2 different things. So on the left side, it has a gear, and the gear is connected to the motor, and on the right side we have the water wheel. So this is the first sketch, and the most noticeable thing, like the most important feature, is probably the cool system. The cool system is connected to the windmill, and it's connected to, at the same time, it's connected to the main shaft. So the second different sketch here is actually the windmill. The windmill has 4 different blades on top, and it's actually connected to a single dowel. And at the end of the dowel, like on the other side, we have a pull system. The pull system is connected to the main shaft. The main shaft is the same as the main water dowel. And when the windmill turns around, it turns the whole system and generates power. So the last sketch here, we have the water wheel. The water wheel has actually the same shaft as the main shaft. So like the dowel is the same shaft as the main shaft. They both have the same thing. So we have a square wood, a square piece of wood in the middle here, and the square piece has 2 different dowels. At the end of each dowel, we have cups, and when the water hits the cups turn around, and the whole system generates power at the end. And so the estimated cost for these 3 different sketches, like the whole power system, is 20 bucks. And now Tyler will take my question.
Thank you, Aziz. So now we're going to talk a bit about the justification of our design. We decided to use 2 different sources of power, hydro and wind power. And for each of these, we have a good reason behind it. As you see, we have a quote talking about hydro sources that more than 50% of the renewable energy generated comes from water. As we know this fact, we decided to have one of our sources of power be a water wheel. And for the next one, as you can see, we based our design for our windmill off of this design here. And original plan was to connect both of these powers using a pulley system. We have cited the sources down here below, as you can see. And here we have our decision matrix. And in our decision matrix, we had 3 original designs. And of these 3 original designs, we gave each of them a different category, and we gave each of these categories a weight. And the overall winner was design number 1, because it had the best efficiency, durability, and cost, depending on the weighted scale.
So now we have here stall torque and nominal speed. Power equals torque multiplied by angular velocity. And we have a graph here. The graph is the relation between torque and angular velocity. When torque equals 0, angular velocity is at the maximum point, and when torque is at the maximum point, angular velocity equals 0. And in both cases, power always equals 0. And also, we use 2 different gears. The first one is 52 gear, and the second one is a 40-tooth gear. We decided to use the 40-tooth gear because it has more torque and it generates more power. And we have here the general idea of stall torque and nominal speed. And now Tyler will take my place.
We had a limited budget of $50. We only used 26.3. Not all materials were used in the actual project. These were the materials that were used in the final project. This is the project development. So that's day 1. That's when we built the water wheel. And here we started building the windmill. And that's day 3. The water wheel wasn't spinning as we intended. It created a lot of mess, and it was hard for us to connect the windmill and the water wheel together. So now we tried to cut the caps of the water wheel in order to make it better, to spin better, but that didn't help. So we stuck with the windmill. We had 3 features or 2 features in our design, which is the blades of the windmill, which were made of the polyethylene. So these were light, and the bearings, which made the half-inch dowel spins and made it easier for us to make the windmill spin without friction.
So we estimated that our score will be 25 out of 30 points. That concludes our presentation, and we're very confident with our build. All right.